Hey guys, this is Mrs. Jeffries, and we are going to do lesson 7 of unit 3 with a little bit of lesson 6 thrown in. So if you turn to page 225, we're going to look at shapes that are not just traditional polygons. And so we're going to look at the state of Nevada and try to estimate its area. Okay, so in order to do that, really, if you look at Nevada, it's like 320 there, 320 miles across. And then if we go across here, oops, that's not very straight. Here, that's also 320 miles across, right? So if we just estimate and pretend this is one big rectangle, we have really a rectangle with a triangle that we need to take out of it. And we're not going to worry too much about this little part right here. So to find the area of the rectangle, we're going to do length times width. So 320 times 490. And that will be 156,800 square miles for the whole rectangle, okay? But we need to find the area of this triangle. And so remember, the area of a triangle is the base times the height divided by 2. So we're going to do the base of 320 times 270, get that answer, and then we're going to divide that by 2. Okay, so it was 84,400, divide that by 2, that gives us 43,200 square miles that we need to cut out of Nevada. Okay, so we'll take that 156,800 minus the 43,200. So we can say that Nevada is approximately 113,600 square miles. So obviously that's not going to be the exact measurement, but it will be pretty close to what it would be in real life. Okay, let's look at the summary just real quick. And so just to remind you that you can find the area of different irregular shapes by just using polygons to draw, around them, and use those like a rectangle is really probably one of the best ones to use. But with this octagon here, they show us that we have a rectangle that goes around, okay, that's 20 units here and 16 here. So we could then find the area of that whole octagon is 320 square units. Well, then you have these triangles, these 4 triangles. Well, if you find the area of one of them, 8 times 5 is 40, that divide that by 2, that's going to be 20 for this one, 20 here, 20 here, 20 here. So what they've done is taken 320 basically minus 80 to get 240. So we want to approximate, so when we need to estimate with irregular shapes by approximating them with the polygon, find the area of the polygon first and then subtract out what you need. And then they show you a great example here with Lake Tahoe. So you can check that out. Okay, now we're going to go over to page 229 for lesson 7, which is where we're exploring the area of circles. So on 229, I gave you some diameters and the estimated area. I took some circles and counted on graph paper what they would be. So take a second, jot those down. So if you had a diameter of 14, I estimated it to be about 156. Diameter of 7 is 40. Diameter of 3 is 7, just for fun. Okay, so wherever the graph page is, I'm not sure what page that is for you, but it should be close. We're going to plot these 3 on the graph. So we're going to go diameter is 3, and then we need to go up to 7. We're going 1, 2, 3, 4, 5. So we're going by tens on the y-axis. So I'm going to go a little below that. And then we're going to go to 740. So you go ahead and do that too. And then 14, 156, 150, about halfway through. So what you'll see is this is not going to be a straight line, is it? So when we look at the diameter compared to the area, it's not going to be a straight line. So back in lesson 3, we graphed diameter and circumference of a circle. So how is this graph the same and how's it different? Well, this one is a curved line. Also, so that's a difference. Curved line here, circumference and diameter is proportional, so it was straight. One thing that's the same is as the diameter, or as the diameter increased, the area or the circumference increased as well. So we can just say increasing line. Okay. So let's look at 7.3 called covering a circle. Okay, so this is where we're going to come up with the formula for this, but we first have to look at what we're dealing with. So here we have, this is called a radius square. And that's because it's made up of side lengths that are the same as this radius. Okay, and so like this side is a radius, and this side is the radius. So the question is, how many of these squares do you think you can cover the circle exactly? So if we do this, go ahead and make 4 radius squares over that circle. So you can pause the video and make yours real quick. Okay, so you should have a picture that looks like this, and we want to be able to cover the circle exactly. So we know that 4 squares is too much. So if we take this square and we cut it in half right here, that's going to be half a square in here, right? So we're going to do that on all of them. Cutting that radius square into half. Okay, so we have these are each a half of the radius square. So if we take 1/2 plus 1/2 plus 1/2 plus 1/2, we end up with 2 squares, right? Well, 2 squares are not going to be enough to cover that circle. So if we look at, we now have basically a triangle, or half of the square. So we have half the radius square left over. If we take this part right here and shade that in, that's about half of that half of the circle, or of the triangle, right? Sorry about that. So what I have left over is this half triangle. And then if I shade in the part of the circle that's in that half triangle, that's about a half of the half triangle, which would be 1/4 of the radius square. Okay, so that's about a 1/4 of the radius square. So if we look at that again, here we have this much of the circle left, which takes up about a half of your radius square that's left over. So a half of a half would be 1/4. So we have 4 of those, right? So here's another 1/4, and here's another 1/4. So if I have 2 squares there, and then I add up 1/4 plus 1/4 plus 1/4 plus 1/4, I have now 1 full square. So that's 1 square. So total, to cover this exactly, would be approximately 3 squares. Sorry, 3 radius squares. Well, what number in math is approximately 3, or a little bit more than 3? So we need to take a moment and jot this down, that it takes a little more than 3, or about 3 radius squares to cover a circle. And that would be for any circle. So we would take whatever the length of the radius is on any circle and make a square out of it. Do that. Well, in math, when we do a radius squared, that's really radius times radius, right? Because we would take the area of that 1 radius square. To find that, we would do radius times radius. So that's the area of 1 square of 1 radius square. Okay, and then times about 3. So let's check that out and see how close we were on our graph over here. So if we take 14, if the diameter was 14, then the radius is 7, right? So if we take 7 times 7, that's 49, and then we take that times 3, because it's about 3, is that 147? That was kind of close to where I was with 156. Now to do that officially, we're going to use 3.14 times 7 times 7, which is 153.86. So it's pretty close. I was pretty close with that 156. Holla. So the main thing to get out of this is that circumference and diameter are proportional. So the circumference of a circle is proportional to the diameter. So we use C equals pi d. Oh, you didn't even see that. I'm sorry. Circumference C of a circle is proportional to its diameter. And we saw that back in lesson 3. The circumference is also proportional to the radius of a circle because there's, you know, 2 radiuses make a diameter. However, and here's the biggie, the area of a circle is not proportional to its diameter or radius. Okay, so here we have highlighted the 3r squared. So the area of a circle with the radius r is a little more than 3 times the area. And we're going to say 3-ish times the area of a square with the side r. Or in other words, 3-ish times the area of the radius squared. Or of the radius square. Okay, so we'll, for now, use that 3-ish times, okay? And then we will move forward with that. So what you need to get out of this area is not proportional to the size of the radius or diameter, but circumference is. Okay, be sure to check Schoology and find out what your assignment is for today. Have a wonderful day.